Hello, I'm Sharon's work group number 9. Our topic is computer machine repair time in a technical service company. We have the project team and company background. Here we have the focus problem statement. Is there a high time of repair of computer with RMA warranty in the technical service company in the city of Guayaquil? In the way definition, we have a high equipment repair time with RMA warranty in days. Here in the implementation plan, we have two Ys. And here we have the improv simulation. In the second time, we have that for the improved in flexing, where we're able to reduce the time from 5.80 days to 3.78 days, reduced to guys by 39%. Thank you.
The Raffaroni method. Step 2 is to calculate values of intervals. And then we conclude that all the scenarios have positive intervals, but the scenario 3 is more adjusted to the objective. We have the current situation and the improved situation. After we implement our solution, we have increased of 200% of throughput and 700% of average increased use of operators. Okay, we realized the analysis, the normality analysis of the current situation, and we conclude that the data have a normal distribution. The process is under statistical control. This is the capacity analysis, and we conclude that the CPK is greater than 1.333. Therefore, it is a process that is statistically in the world-class range. The triple bottom line, the social, environment, and the economic. The economic benefit after we implement our solutions. The most valuable are the visual control and the staff training, $200 each one, and the investment is expected to recover in approximately 2 months. We estimate those values. The control plan we propose for our two main solutions that are visual control to identify the shortage of parts and the stock training and evaluation plan. And finally, the reaction plan. The training plan, as mentioned previously, is also for the operators of the areas prior to repair, since they have low utilization shown in the simulation. For this reason, they can perform the tasks as shown here. Thank you.
Here we can observe the visual control tool A3, in which we present the problem, the definition, the current conditions, the action plan, and the control plan. Continuing with the agenda, we have the current situation simulation. Here we can observe the verification made of our simulation in FlexSim by the engineer Yoshiro, and at the bottom, the process flow. Here we have the dashboard presented in FlexSim with the times of each process, the reception, review, replacement, repair time. Using FlexSim, as you can see, we have 5.9 days in our cycle time. Then we have 4 charts that show the variability of time achieves each of our processes. Here we observe the comparison made between the data given by FlexSim and the observed data. And by that, we need to analyze if the average cycle time is the same or if it's different. That's why we apply the hypothesis test, in which the null hypothesis is not rejected. It says that you don't reject HO. So the flexing model is suitable. And finally, we have the power test, in which the sample size is calculated, which in this case is equal to 10.
Proposed solution. In this particular diagram, it can be seen that no spare parts and work methodology are the root cause of problem. 4 solutions were proposed: MRP, visual control, staff training, and instruction for repair. The economic analysis in this part, the implementation of each strategy to be developed was cost. An impact if 4 matrix was made, where solutions 2, 3, and 4 were chosen. The implementation plan, this was implemented to affirm root cause, and 4 solutions to this problem were proposed by making an implementation schedule. The implementation schedule is detailed with activities, start date, and end date. Visual control identifies the amount of victory by means of cards. Staff training is used to improve the performance of operators. There are other conclusions, and there are recommendations. Thank you.